So today we're going to talk about 6-6, which is all the methods to solve a matrix. But first let's do a little review. Let's multiply these two matrices together. So this first matrix is a 1 by 3, 1 row, 3 columns, and this matrix is a 3 by 1. So as we learned yesterday, if the dimensions on the inside here match columns by rows, and they do, that means my new matrix will be a 1 by 1. So that means I would take negative 1/6 times 12, which is negative 2, plus 1/2 times 0, which is 0, plus negative 1/3 times negative 12, which is 4. So that gives me negative 2 plus 0 plus 4, 2. Now on this next matrix, I have a 2 by 2 times a 2 by 2, and again those match, so I should get a 2 by 2. So I'm going to make my 2 by 2 spots. So row 1 by column 1 gives me negative 6 times negative 1 is 6, plus negative 2 times negative 5 is 10. Row 1 column 2 gives me negative 6 times 4, negative 24, plus negative 2 times 3 is negative 6. Then we have row 3 by row 1, and that gives me 0 plus negative 15, and then row 3 by row 2, row 3 by column 2 gives me 0 times 4 is 0, plus 3 times 3 is 9. So my result is 16, negative 30, negative 15, 9. Again, the question is matrix multiplication commutative? The answer is no. That is the only property that does not hold true with matrix multiplication. All right, so let's actually start today's lesson. First of all, we'll deal with inverses. In order to teach you what inverses are, I first have to let you know what the identity matrix is. The identity matrix is a matrix with 1s on the first diagonal and all other elements of 0. They are only square matrices. So if you see here, this is the identity matrix 2. Why it's just a subscript 2 is because they're square, so it's a 2 by 2. Notice we have this first diagonal is 1s, and all my other elements are 0. Again, the identity 3 by 3, this first diagonal is 1s, all other elements are 0. Okay, so what happens when we multiply the identity matrix times matrix A? Well, matrix A is a 2 by 2, so the identity I'm going to use is a 2 by 2, so 1, 0, 0, 1 times 2, 4, negative 3, 1. 2 by 2 times a 2 by 2 should give me a 2 by 2. So row 1 by column 1 gives me 2 plus 0 row 1 by column 2 gives me 4 plus 0. Row 2 by column 1 gives me 0 plus negative 3. And row 2 by column 2 gives me 0 plus 1. So my result is 2, 4, negative 3, 1. So notice when I multiply the identity by a matrix, I get that matrix back. It's just like taking 1 times 3, it gives me 3 back. When I multiply the other way, 3 times 1 also gives me 3 back. This is called the multiplicative identity. So let's see if that works with multiplication. So this time I'm taking 2, 4, negative 3, 1 times the identity, 1, 0, 0, 1. 2 by 2 times the 2 by 2. So I've got 2 times 1 is 2, plus 4 times 0 is 0. That gives me 2. Then 2 times 0 is 0, plus 4 times 1 is 4. That gives me 4. 3 times 1 is negative 3, plus 0 times 1 is 0, gives me negative 3. And negative 3 times 0 is 0, plus 1 times 1 is 1, gives me 1. That also works. So the only way matrix multiplication is commutative is if you multiply it by the identity. Now I have the identity, the additive identity shown. If I take 3 plus 0, I get 3. Likewise, 0 plus 3, I get 3. So no matter what I do, when I add, the identity element of addition is 0. So the identity matrix of addition is 0, 0, 0, 0 if I have a 2 by 2 0 matrix. Notice how the 0 matrix is written. Here's a couple new terms for you. If a matrix is considered invertible or non-singular, it means the matrix has an inverse. It also means that there will be a unique solution. If a matrix is considered singular, it means it does not have an inverse, which then means your solutions are either no solution or infinitely many solutions. Non-singular means there's an inverse and you have one unique solution, whereas singular means no inverse, so it is either no solution or infinitely many solutions. Okay, another term is what is an inverse matrix? It is the matrix that is multiplied by another whose product will give you identity. We denote it as a to the negative 1. So let's see if we have an inverse here. It says the matrix that is multiplied by another and their product should be the identity. So if this is the inverse, I want to see if A inverse times A gives me the identity of a 2 by 2. So negative 5, 3, 2, negative 1 multiplied by 1, 3, 2, 5 should give me negative 5 times 1 is negative 5, plus 3 times 2 is 6. Negative 5 times 3 is negative 15, plus 3 times 5 is 15. Two times negative 1 is 2, plus negative 1 times 2 is negative 2. 2 times 3 is 6, plus negative 1 times 5 is negative 5. So that gives me my result of 1, 0, 0, 1. So it is the identity. So this is A inverse. All right, before I can teach you how to do an inverse, I also have to teach you about determinants. A determinant is the difference of the products of the diagonals of a square matrix. This is how we denote determinant. It's like saying the absolute value of matrix A. So the difference of the products of the diagonals. So other notation we can use is DET of matrix A. So if you look at this one, I'm looking for the determinant of the matrix A, B, C, D. So let's see the difference of the products of the diagonals. So this blue diagonal is AD. Difference means minus. The red diagonal is CB. So this determinant would be AD minus CB. So let's try this one. This first diagonal be 7 times 3 minus the second diagonal, 2 times 2. That's 21 minus 4. That's 17 for my determinant. This next one, first diagonal, 10 minus second diagonal, 10, gives me a determinant of 0. Third one, 3 times 1 is 3, minus this diagonal is 24, gives me negative 21. So what this shows us is that the determinant can be any kind of number. Positive, negative, 0, fraction, any number works. If you are finding the determinant of a 3 by 3 by hand, what you want to do is copy your first 2 columns. So 4, 1, 2, 2, 1, negative 3. So now I'll have 3 diagonals. So I want the product of those 3. So 4 times 1 times 5 is 20, plus 2 times 0 times 2 is 0, plus negative 1 times negative 3 is 3. So there's my first 3 diagonals, products. So the sum of the product of the diagonal minus the second set of diagonals. So I should have 3 diagonals this way now. So I have 2 times 1 times negative 1 is negative 2, plus negative 3 times 0 times 4 is 0, plus 5 times 1 times 2 is 10. So I end up with 23 minus 8, which is 15. I have a separate video to show you the calculator use and how to get a determinant. So you'll just have to check that video out as well. Now we can find the inverse. So the inverse of a matrix is we do every single one of our inverses. So notice inverse of matrix A. We reciprocal the determinant. Notice then we have DA. We switch the first column. We negate the second diagonal. So it is first, find the determinant. Second, reciprocal that. Third, switch. Fourth, negate. And last of all, multiply your scalar. Okay, so we're going to try this one. First, we need the determinant. That is 12 minus 4 is 8. So to find the determinant, it would be the reciprocal of 8, which is 1/8, times, I'm going to flip this first diagonal, so 4 and 3 flip, negate the second diagonal, so this is a -2 and a -2. So this gives me 4/8, -2/8, -2/8, 3/8. And I'm going to suggest that when you find your inverses, you leave them in non-simplified form. So let's try this one. Determinant is 12 minus 12 is 0. So A inverse will be reciprocal, which would be 1/0, times switch, 3 and 4, negate, -2, -6. So when I try to multiply 1/0 through, I cannot do it because 1 does not divide by 0. You can never, ever divide by 0 because you don't get a number that works. So this says solve the matrix using the equation AX equals B. Well, in this case, matrix A is your given matrix. Matrix X is your variable matrix. And matrix B is your solution matrix. So anytime you see the notation AX equals B, we want the given matrix times the variables times the solution. What I mean by the given matrix, maybe I should say it as the coefficients. All right, so to solve this, I need to multiply this by A inverse. You must always multiply the inverse in front of the matrix. So I need the inverse of this matrix A. So the determinant would be 21 minus 20 equals 1. So A inverse is the reciprocal of 1, which is 1. Flip, -7, -3, negate, -4, -5. So A inverse is -7, -4, -5, -3. To find matrix X, we have to take A inverse times 3, 8, 2, -2. So to find X, I take A inverse, -7, -4, -5, -3, times 3, 8, 2, -2. So that gives me -7 times 3, -21, plus -8, -56, plus -4 times -2, 8, -5 times 3 is -15, plus -6, -5 times 8 is -40, plus -3 times -2, 6, which gives me the result, -29, negative 48, negative 21, negative 34. And that is exactly how I want you to show your work. Okay, to find the inverse of a 3 by 3, there is no special method other than to use your calculator. So again, you're going to have to watch that video to get that answer. And what you should get is 3, 0, negative 1, 7, negative 1, negative 2, 6, negative 1, negative 2. All right, rewrite the matrix in the form AX equals B. Again, that means coefficient matrix times variable matrix equals solution matrix. So this means coefficients 2, negative 3, negative 3, negative 4, times variables. My variables are X, Y, should equal my solutions of 7 and 9. So to solve this, I need to do A inverse in front. So this determinant, negative 8 minus 9, again, equals 1. So A inverse is the reciprocal of 1, which is 1, times this flipped, negative 4, 2. This negated, a 3 and a 3, gives me negative 4, 3, 3, 2. So to find what X and Y are, it says to take A inverse times 7, 9. So I need to take negative 4, 3, 3, 2 times 7, 9. 2 by 2 times a 2 by 1 should give me a 2 by 1. Negative 4 times 7 is negative 28, plus 3 times 9 is 27. 3 times 7 is 21, plus 2 times 9 is 18. So X is a negative 1, and Y is a 39. Okay, we're going to do the same thing here. It says AX equals B. So first, I have my coefficients, 4, negative 3, 2, negative 1, 4, 3, negative 2, 0, negative 5, times my variables, X, Y, and Z, equal my solutions of 8, 2, and 2. So again, to solve it by inverses, I have to take A inverse times the front. Only way I'm going to be able to do this is on my calculator. So I'm going to have to do the inverse of this matrix and multiply it by this one. So to get X, Y, and Z, I would take A inverse, which comes out to be 4/17. Oh. Oh. you get 224 over 31, 148 over 31, and negative 102 over 31. To do it by reduced row echelon form, that is where we will use an augmented matrix. So our augmented matrix is 4, negative 3, 2, 8, negative 1, 4, 3, 2, negative 2, 0, negative 5, 2. So you enter that in your calculator, and then you choose RREF. And again, these directions are on my calculator slide, and you should get 1,00224 over 31, 148 over 31, and 001 negative 102 over 31. So again, this is my X, this is my Y, and this is my Z. So I get X is 224 over 31, Y is 148 over 31, and Z is negative 102 over 31.